Hello, and welcome to this short presentation introducing the Bachelor of Science in Robotics and Intelligent Devices. My name is Dr. Rudy Villing, and I am the director of this program. The Bachelor of Science in Robotics and Intelligent Devices is a unique four-year degree blending electronic engineering and computer science. The degree focuses on intelligent physical things in the environment, things that continuously sense, think, and act. For example, robots, autonomous vehicles, smart sensors, Internet of Things devices. It has applications in health and well-being, smart manufacturing, retail, and hospitality. The program helps you develop a strong CV, whether you choose industry or research as your next step after the degree. It contains a 6-month work placement opportunity with relevant employers in third year, and you have the chance to create a portfolio of projects to show potential employers. Projects and practical work are included in each year of the program. We have excellent facilities, friendly learning environment, engaging and expert staff. You'll have access to both the electronic engineering and computer science laboratory facilities as part of this program. Normally, CAO entry requires between 360 and 400 points. In 2020, it required 361 points. You need to have Irish, English, and an O3 or H7 in mathematics. Overall, you need 2 H5 and 4 O6 or H7 qualifications. It is possible to transfer to Year 2 of MH304 Electronic Engineering after completing Year 1 of this program MH306. Before we move on, here is an outline for the remainder of the presentation. First, we will talk about what is an intelligent device and what is our robotics focus in this program. Then we'll look at the program objectives and structure. Next, we'll look at who does this program suit and why should you choose this program. Finally, we'll look at the opportunities and conclusion. An intelligent device might be any type of equipment, instrument, or machine that has its own computing capability. An intelligent device can usually sense some aspect of its environment and make inferences based on that sensing. Intelligent devices include medical technology or health technology, such as health trackers, pacemakers, diagnostics and baby monitors, or home systems such as smart ovens, adaptive heating systems, security systems, or apps that control music, TVs, etc., and various kinds of gizmos and toys. There are so many different categories of robots in the world that it is not feasible to deal with all of them. We primarily focus on 3 main categories. Social, domestic, and service robots are the robots that we will see at home, at the shops, at the hotel, or in the hospital. They assist with everyday tasks. Collaborative and light industrial robots are those that you might see on the factory floor, on the assembly line, or on a packaging line. They are adaptable and can work safely alongside people. Unlike more traditional industrial robots, they do not need to be surrounded by a safety cage. Autonomous vehicles include autonomous cars, drones, and mobile robots for post or package delivery, inspection, and similar tasks. We don't really work with heavy industrial systems. These typically do not involve that much intelligence, which is our area of interest, but instead repeat the same tasks very precisely over and over. Ireland does not generally have a large heavy industry base, so we feel that it is of less interest in this country. Instead, we are more interested in robots and devices that must operate alongside people and must incorporate real intelligence. Now we will look at how this program works in practice. We would like our graduates to be able to add intelligence to everyday objects, to enable mobile devices to operate in unplanned and dynamic environments, and to provide safe, friendly, and easy interactions with humans. We would like you to be able to develop for a range of applications that includes intelligent home systems, wearable systems, industrial mobile robotics, home-based robotics, and human interactive robotics. To prepare you for all this, we provide you with the hardware and software skills that are needed. Let's take a look at the overall structure of the program and how it prepares you to work with both robotics and intelligent devices. It's a 4-year program, and both computer science and electronic engineering modules are combined throughout. The boxes on the diagram are indicative of the number of modules provided by the departments. Software and hardware skills are developed quite equally throughout. Computer science delivers most of the software, but some device-oriented programming modules are delivered by electronic engineering also. Electronic engineering delivers the hardware and engineering modules. Core features of the program include the development of strong programming skills in languages such as C, C++, Python and Java, electronics and hardware design, a number of robotics-specific modules, and advanced techniques, including machine learning and optimization. We also give consideration to human-machine interactions, social awareness, cultural issues, fears, and trust. Projects are a key feature of the program, and each year you will develop and use a variety of robots and intelligent device technologies. On completion of the program, you will have a portfolio of projects that you can use to give employers a very good sense of your capabilities. In first year, the focus is on a broad foundation and bringing everyone to a baseline standard of mathematics, physics, computing, and electronics. The Robotic Systems project takes place in semester 2 and uses the Arduino-based MakeBlock robot kit. Some of you might have encountered the Arduino before. The project is designed for teams of 3 or 4 and is your introduction to basic sensors and the sense, think, act loop that underlies all intelligent systems. It's also your opportunity to encounter firsthand the difference between the ideal world and the real world that your robot and sensors operate in. An example project might be to develop a robot to drive around an uneven track as fast as possible while carrying an unstable load. In second year, we focus on developing your skills in mathematics, electronics, and computing. The Intelligent Systems project, in semester 2 of second year, is an audio and vision-based project using the Raspberry Pi and a webcam as the target platform. It is designed for teams of 3 or 4. This project uses more advanced computation and sensing capabilities than those used in first year. Example projects might include a smart door lock that unlocks the door by recognizing your face, or a device that can recognize the sounds of one specific species of bird. Third year develops skills in probability and statistics, signals and systems, control, and robotics and automation, among others. In semester 2 and over the summer, there is a 6-month work placement with relevant companies. Substantial design exercises are available as an alternative if no placement is obtained. We have been involved in RoboCup robot soccer for many years and have sent teams to compete in many international events. You have the option of participating in the team on an extracurricular basis, and committed team members have the potential of travelling to international RoboCup events. Most recently, RoboCup 2019 was held in Sydney, Australia, while RoboCup 2021 is to be based in Bordeaux, in France. Fourth year introduces the most advanced undergraduate topics, including machine learning, computer vision, computer control systems, and specialized robotics modules. Final year is also when you work to develop a substantial piece of work on your own. This Capstone project allows you to integrate what you have learned and apply it to a research or industrially relevant problem. This will be in an area that interests you, matched to the expertise of our supervisors. You have the option of proposing your own project or selecting from a range of projects proposed by our supervisors. Projects have included traffic counting using computer vision, teaching robots to interact with people to play games, teaching an intelligent camera system to classify strawberry ripeness, and helping to rehabilitate people after a stroke with the use of a brain-computer interface, among many others. So is this program for you? Are you interested in making things, combining electronics and computing or software? Are you someone who likes creating solutions, solving problems, inventing? Perhaps you're interested in technology and people and how they emotionally and physically interact. Are you maybe a candidate for the technology section of the Young Scientist competition? Are you adventurous and curious? Things that would benefit you but are not mandatory would be mathematics skills beyond the H703 requirement, physics, and an interest in computers and programming. If this sounds like you, then this program would be well suited to you. Sometimes people are a little concerned about the level of mathematics that might be needed for this program. But we have people enter the program with a variety of mathematical abilities and succeeding all the time. The important thing is that this is applied mathematics, practical mathematics. There is support available to help if needed, and the key thing is to eliminate any fear of the mathematics. If it is an area of weakness for you, just prepare to spend a bit more time on it to compensate. Some key topics are statistics and probability from strand 1, geometry from strand 2, and functions from strand 5. Another reason to choose this program is for its employability. Here you can see just a small selection of the companies nearby who have a real interest in the desirable skill set of our graduates. The companies range from well-known multinationals to indigenous SMEs. As you know, the robotics and intelligent devices industries are predicted to grow hugely over the next 10 or 20 years, and this only serves to make the program more relevant. Another reason to choose the program would be to gain early access to new areas. For example, assisted living in the home, or prosthetics and medical technology, or perhaps developing intelligent technology for our smart homes. Other new areas include the retail and hospitality sector, making deliveries using drones, and the growth of self-driving vehicles. Ultimately, this is a program that gives you great opportunities. Graduates will have both computer science and electronic engineering skills, and will get jobs in either of those areas. In summary, this program provides a new combination of electronics and software with exciting career opportunities in non-traditional areas. If you thought that tech is boring and cold, we believe that this program will change your mind. Robotics and intelligent devices will change the world we live in. There are strong, in-demand, well-paid career opportunities in Ireland and globally. For more information, please visit our website at www.maynoothuniversity.ie/electronic-engineering or email electronic.engineering@mu.ie. Thank you.